going to tell you the answer, but I'm just going to tell you which one's going to be going into which group. So the second one was butane 2-ol. That is an example. So 1, 2, 3, 4 alcohols on carbon number 2. Filling in my hydrogens. That's an example. Next one on that list was butane 1-amine. That is a non-example.
But how do you know where to put them?
I will tell you, but I want you guys to figure it out first. Maybe when you see all the group, you might figure it out. Okay, 1, 2, 3, 4. Amine's over here.
Oh, wait. I think these ones have like
Okay, next one on that was butane-on. So that is our ketone. That is not an example. You guys are going to kick yourself once you realize. Oh, am I going to have enough room for my hydrogens?
I think it's in the functional group.
Okay, next one is 2-methylpropane 1-ol. That is an example.
So the example is alcohol. Yeah. Yeah, I think so. They all have
Okay, the next one is 2-methylpropane 2-ol. That is an example. The next one I have is butanal. That is a non-example. The next one is 2-methylpropane. That is also a non-example.
I think examples have alcohol, right?
Getting close. All right, I'm going to give you guys one more that I forgot to stick in there because I can hear whispers, and I realized that actually I should have stuck in one more. I'm going to stick in propane 1-ol, and propane 1-ol is not an example. So that one is an alcohol, but it's a non-example. Interesting, 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 interesting. All right, now you guys have everything. These are examples of what I'm talking about. These are not examples. Now, Baha got close because she did talk about of alcohols, and you're right, all these guys over here have alcohols, and then I was like, I'm going to stick another alcohol in here, and then I confused you, and I put it in my non-example. All right, so we know everybody on this side has an alcohol. What's the other thing that all these guys here have in common? Same amount of what? Carbons. So these have the same structure, same molecular formula. So all of these guys over here, if you went through and counted them, they have how many carbons? 4 of them. How many hydrogens do they have? That one has 3 plus 3, 6, plus another 3, that's 9, 10. Does this one also have 10? 3 plus 3, 6, 7, 8, 9, 10. 3, 3, 6, 7, 8, 9, 10. So they all have 10. How many oxygens do they have? 1. So this has the same molecular formula. That's what we call when we say molecular. All right, the magic word was talking about structural isomers. So these here are examples of structural isomers with this molecular formula. So these are examples of structural isomers of C4H10O. So all these guys have the same molecular formula. So here's my molecular formula. So the key thing to keep in mind about structural formulas is they have the same molecular formula. They just have different bonding patterns. So we see in this case, this alcohol is on carbon number 1, whereas this alcohol is on carbon number 2. Both of these are examples of straight chains, so they have no branches. So these two are examples of structural isomers. They have the exact same formula. The only thing that's changed is where I put this alcohol. These two are also structural isomers of the first two. The difference is that we've moved the N carbon and we've chucked it onto carbon number 2. So now we have a methyl branch. But the carbon number still stays the same, and I've done a little bit of a play around where that alcohol was, if it was on carbon 1 or carbon number 2. So these are examples of structural isomers. These guys over here don't fit as examples of the structural isomers to this guy because they have a different functional group, like this guy here. This one's wrong functional group altogether. This one here is 1 less hydrogen. So that's 3 plus 3 is 6, 7, 8. Actually 2 less. So that's why that doesn't match. Same with this guy. But the good news is, these two, would they be structural isomers of each other? Yes, same molecular formula. So these are structural isomers C4H8O. See what I'm saying? This one over here doesn't fit with anybody because it doesn't have any functional groups. It's just carbon and hydrogen. This one over here, even though it is an alcohol, is not a structural isomer of the examples because it has 1 less carbon. This is going to be a really fundamental thing that we need to understand for spec. All right? Questions, concerns, comments? Does that make a bit more sense? Yes. Shika. I will always post it on my website. It is recording. Don't worry. I figured you guys probably need a couple of times just to get this in your head. All right. How are the rest of you guys doing? Does this make sense? All right. Let me just see what else I have planned for today's lesson. So we've done the notes. All right. Shall you guys try it? Yes. Yeah. Okay. So no, we're done with that. Okay. I'm giving you a molecular formula. I'll make this a little bit bigger. And this molecular formula is of a hexane because there's 6 carbons there. But there's different ways you can arrange those 6 carbons to make different molecules. There are a total of 5 different ways you can arrange that. And I want you guys to see if you can find all 5. Chico's looking at me a little panicked. Just give it a go. So you already know one of them, and that's hexane, correct? Straight chain, 6 carbons in a row. Now figure out to move the carbons around to make branches to then figure out the other 5 molecules. Or other 4 molecules, sorry. And you guys can grit your teeth at me. Be so mad. All right, here's the answer. I'll take your scripts. Are you done? You need more time still? You don't have to write that much. That's what I'm saying. All right, so everyone got this one. This one is hexane. Give me a face. Everybody got this one. This one's hexane. The trick is to take the N carbon and to start moving it. Will I move it over here? No. Will I move it over here? No. Why? It's still hexane. Move it over here. Now I have 1, 2, 3, 4, 5 pent. The carbon's on carbon number 2, so 2-methylpentane. If I move it over here, do I have 4-methyl? No, it's still 2 because I go 1, 2. So 2 molecules so far. Third molecule is this one. It is now 3-methylpentane. Good? Name them if you are not sure. All right. I can't do anything else, so now I'm going to be moving this carbon over here. Do I want to move it over here? No. That's still the longest chain. Do I want to move it over here? No. That's still the longest chain. I can move it over here. Correct? Now I have 2,3-dimethyl, what's it? Butane. All right? And then last one, if they're on the same carbon, 2,2 dimethyl butane. If I do this, now we're back to 2,3. If I do this, we're back to 2,2. That was the answer. Those are the 5 molecules. Oh my god, miss. This is terrible. Why are we doing this? We're going to do some more practice, don't worry. You're like, miss, I do not like this game.